Oh, hello again, Dom. Welcome back to another riveting chapter of doing math the hard way, because apparently built-in functions like exponentiation are for wimps. Today we're encouraged, to understand how to manually calculate powers using just multiplication and sheer stubbornness. That's right, no easy shortcuts allowed. It's like being told to climb Everest barefoot because it builds character. So here's your challenge, folks. Take a number, call it A, and raise it to another number. Let's call that one B. And here's the hilarious kicker, you can't use any built-in exponent functions like circumflex, pow, or asterisk. No, that would be cheating, apparently, Wham. Instead, you've got to painstakingly multiply the base by itself again and again like some medieval math punishment. Example? All right, fine, I'll spoon-feed you. If you're trying to calculate 2 raised to the power of 5, it's basically this: 2 times 2 times 2 times 2 times 2. And before you embarrass yourself by pulling out a calculator, it's 32. You're welcome. Exponentiation, at its core, is a posh way of saying, multiply this number by itself until you run out of fingers, patience, or sanity, whichever comes first. It's how mathematicians make simple multiplication sound impressive. Let's face it, 2 times 2 times 2 doesn't sound nearly as impressive as 2 cubed. They had to invent fancy words just to feel smarter. There are some basic rules that even your math teacher probably mumbled in their sleep. Anything raised to the power of 0 equals 1. Don't ask why, it's math's equivalent of because I said so. Anything raised to the power of 1 equals itself. Profound, I know. So how do we tackle this ridiculous problem without using any helpful shortcuts? Glad you asked. We take a simple loop, start from 1, the most boring number ever invented, and repeatedly multiply it by our base A, exactly B times. Yes, exactly as mind-numbing as it sounds. It's like manually inflating a massive balloon using nothing but your rapidly diminishing lung capacity. You know there's an easier way, but here we are puffing away like absolute idiots. Let's painfully walk through a simple example. 2 raised to the power of 5. Start with a result of 1. Already exciting, isn't it? Multiply by 2 once, now it's 2. Multiply by 2 again, 4. Starting to feel the adrenaline? Multiply by 2 again, 8. Wake me when it's over. Multiply by 2 again, 16. Multiply by 2 one last time, 32. Congrats, you've just wasted precious life moments manually computing, something your smartphone would have handled faster than you could complain about it. Exponentiation is actually everywhere, annoyingly enough. Cryptography uses it because security nerds love complicated things. Computer graphics needs it to make pretty explosions. Financial calculations use exponentiation to depress you with interest rates. Scientists use it to make themselves look busy. So, as tedious as it is, understanding it is kind of important, mostly because other people say it is. Our loop approach works fine if you define fine as painfully slow when dealing with big numbers. For large exponents, our innocent little loop becomes as sluggish as your grandmother trying to operate Netflix. There's a more sophisticated method called binary exponentiation, which sounds smarter because it is smarter. It reduces computations significantly, making you wonder why we wasted time on the straightforward loop to begin with. But hey, we all got to start somewhere, like the bottom, apparently. Why teach this painfully basic method? Here's the official excuse. It teaches fundamental looping concepts, helps you understand mathematical logic deeply, prepares you to appreciate efficient algorithms later by forcing you to suffer the inefficient ones first, shows how different programming languages torture programmers differently. Fun. A few annoying exceptions and considerations. Exponent 0, anything raised to 0 equals 1 because math likes messing with your head. Negative exponents, not covered here because life wasn't miserable enough already. Overflow issues for large exponents, your computer might just throw its hands up and quit. A bit like you during math exams. So that's iterative exponentiation. Easy, tedious, and educationally valuable in the same way eating plain rice is nutritious. Technically good for you, but about as enjoyable as watching a documentary on wallpaper. Next time you press circumflex on your calculator. Spare a thought for the poor souls who had to compute this manually. Or don't, I'm not your therapist.